This is the video demonstration for the 2020 Fall Team Project for LC1 Team 3. These are all of our team members down here. First, we're going to touch on the uses of edge detection in specifically civil engineering. The first use is the detection of cracks or breaks in structures, specifically bridges is what it's currently used for. Detecting cracks with edge detection in image processing software eliminates the need for engineers or inspectors to be on site at the bridges and is time and cost efficient. The second use for edge detection can be monitoring the progress of construction projects, especially projects that contain repetitive structures. In the example given in our source was these repetitive concrete columns here. Edge detection can be used to identify and count how many of these concrete columns have already been constructed, which can then automate the monitoring of the progress of the construction project. This also saves time and money as it eliminates the need for the engineer to be on site to count those by hand and monitor the progress in person. The third possible use is still a theoretical use and is still being explored, but is the real-time identification of potholes in the road. And this would improve safety by uh, giving alerting drivers to potholes in real time, and this would help civil engineers be able to identify the potholes for repairs more quickly, as well as identifying causes of potholes and, of course, overall improve safety for drivers.
Okay, so my name is Patrick Basinger, and I'm going to be doing a quick overview of the code and then doing a few examples of the code working and some error checking. So here we can see we imported NumPy, Matplotlib, and math. We can see where we defined the grayscale function using the equation, the blur function using the kernel, the box blur with the average. That's why there's a 9. The Sobel function using the kernel -1, 0, 1. Sobel y, -1, -2, -1, so on. We have our threshold function, so if the pixels value is greater than the threshold, it's 0. If it's less than, then it's 255. Then we get to the main code where we take the inputs for the file name and check for it ending in PNG. If it's not, prompt them to input again. Then we read their image. Then we take the input for threshold. We give a recommended value of 110. Then we have error checking for the threshold. Make sure it is a valid number between 0 and 255. Then we convert the image to grayscale using our function. Save that image. Define values for the height and width of the image. Blur the image and save that. Apply Sobel X, save that. Apply Sobel Y. Then combine those two images and then save that combination using the gray CMap. All of these saves use the CMap gray so that it is black and white. And then finally, right here we apply the threshold function again with CMap gray, so it's black and white, and this will be our final save, and then we show it here. So the first example I'm going to do is I'm going to run code. We're going to do coins.png. And then, as you can see, recommended is 110 for the threshold, so I'll just do that. And it'll take a second to run. And then you can see it shows up here in the plot section. That's why we have the mshow. But it also, if we go into File Explorer, we have each part of the process. We have gray, we have smooth, then we have edge enhanced, and then the final. So let's do it again with this, but with this arch image. So let's run the code again. Arch.png. We'll do 110 again for the threshold. Again, it'll take a second. Okay, now it's done. We can see it here in the plots, but also if we go in the File Explorer, we see each part, gray, smooth, edge enhanced, final, just like with the coins. And then with my last example, this surgery, I'm going to show some error checking. So if we run the code, instead of doing .png, let's say we accidentally said .jpg, and it'll say it's not specified as PNG. It needs to have a valid .png extension. So no matter how many times we type it, it will keep prompting us until we input a valid PNG file. So let's go ahead and do that. And then the same thing with the threshold. It needs to be between 0 and 255. So if I do 256, it'll give us an error and say, please input between 0 and 255. So again, if I can do this as many times as I want, but until I put a value between 0 and 255, it won't run. So let's go ahead and do the 110, which is recommended. Again, it'll take a second to calculate. Okay, there we go, and we can see that the image has the edge detection here in plots, and same thing as all the other images. All the steps are shown here in the File Explorer.